no clock in this room. 5 minutes. Let's do one more of these average rates of change, and then we'll see how the quiz looks. We have to come back to the quiz on Wednesday. Okay, so let's change the question. Not average rate of change for the whole trip. Why don't we change this to average rate of change from 5 seconds until the end. Average rate of change from 5 seconds until the end. Now, why would I want to do this? Why would I want to do this? Well, Amber?
That's kind of where you started really moving.
Good. It's a better indicator of when things kind of ramped up a little bit. Good. I wish I could say that I was thinking about that. It's a good point. I picked it kind of arbitrarily in the middle. But good. Good for you. It leaves off those slow beginnings. So what this would be, it's still going to be a linearization of what's actually going on, which means it's still going to be wrong, but it's going to be less wrong than the whole trip. And here's why. Let's take this out of the way. I'm going to go back to the board over here, this little graph. Halfway, 5, well, I'm calling it halfway, it's 5 seconds. 5 seconds would start here and then go there. Do you see how the slope of that line is steeper? It's still not steep enough. It's still not steep enough to capture how fast I was going at the end. But it's steeper, which means it's more correct. We'll deal with the increase in steepness probably on Wednesday in class. But the question right now is, can we figure out what we need to calculate this slope? Well, we know that this is 5 seconds, correct? What was the distance at 5 seconds, friends?
58.05.
Listen to that! 50! Chelsea, how did you do that so quickly? Oh.
I did the trace and then...
You can just hit the trace button. Hit the trace button on your machine. Hit the trace button on your machine. Hit the trace button on your machine, and then simply type in 5. Hit enter. 58.0. 58.1. 58.1 is totally fine. Cheating? No, it is not. Don't even mention that to me. Using computers for their intended design? Yes, it's cheating.
You ain't cheating, you ain't trying hard enough.
58.1 feet. So now the question I have is, can we use, I think we really need it. We've got 2 y's, we've got 2 x's, don't we? We've got 2 y's, we've got 2 x's, which means the average rate of change from 5 until the end, all we got to do is figure out how much distance did I cover between 5 and the end. Well, I went from 58.1 feet to 200 feet, yes? So what's that going to be? 141.9 feet? Did I do that right? Is that fair? Did I do it right? 141. Oh, I said it right. I wrote it wrong. 141.9 feet. Thank you. Wrote it wrong. How much time?
5 seconds.
5.1, right? Put the 0.1 on there just to keep our units consistent. Yeah, fair. So in feet, divide that out. What does that come out to in feet per second? Be brave. This, what's 141 divided by 5? 23, 28 point? A little bit louder. 38, so 28.4 feet per second. Which as a conversion, I'll cheat. Use your word.
Yeah.
28. What was it? 28.4. 19.4 miles an hour. But that's not right either, is it? That's not right either, is it? Because that again is underestimating my speed in the beginning and overestimating it at the end. Excuse me, I said that backwards. It's making me go, that's assuming I was going that speed the entire time. Amber, go!
So isn't that's the speed between the 5 and...
Yes, ma'am. What I really need to do here is I need to get the speed between 200 and 200. What? I know, show me. Exactly. What the hell are you talking about? Now you're talking crazy talk. I'm getting at something here. I'm going to paint the picture for next time. We'll come back to it on Wednesday. We'll be back in the library on Wednesday. Apologies. Unless you like this room, I can try to get it back. Move to the library? Library. The idea is this. Shelby, I want to focus on this graph I've got drawn over here. So when you look at the lines I've drawn on this graph, the problem is they're both lines. I've got a green line and I've got a blue line. As soon as I make the lines, they're not the curve that's actually going on with my speed. So what I need to do is essentially make the line curve. Well, I can't do that. A line doesn't curve. But what I can do instead is I can make the curve linear. Now you might say, oh, time out. How can you make the curve linear? And this is what we don't have time to do in class today, but bring your TIs back next time with the data. And I'm going to show you, if you zoom in close enough on any curvy curve, like a parabola, sections of it look linear. And you can actually calculate the slope in a tight enough section to approximate. And that's exactly what your little speedometer of your car does. And that's exactly what the policeman, you guys ever have the hairdryer pointed at you? Get a speeding ticket, hairdryer pointed at you? Guess what the hairdryer's doing? The hairdryer is doing this.
Oh, but it's only picking up the average.
It's what we're doing.
Yeah, right.
That's what the A stands for, my friend. But the average that the little hairdryer is picking up is not 5 seconds apart. It's fractions of a second apart. We're working up to that. We're down to that. Yes, and that's what we'll do next time. But we don't want to do them by hand too much more because the math is going to get tedious. There's some cool TI shortcuts. So bring that quiz back with you next time. Bring that quiz back with you next time. We'll work through. We'll learn some more TI shortcuts and some fun stuff. And there's a quiz to knock out for next time if you want to get in there.
Do you want us to have it finished by now?
No, don't. I mean, if you want to look at it and do some of it, my intent for the quiz was to learn some more technological trickery. Yes, this second enter thing. Yeah, don't worry about finishing the quiz. We'll finish the quiz together next time. Okay? We'll do some more data collection. Thanks, guys. We'll see you Wednesday.